Hi. So the first question is, what difficulties did you have in your game? One of the biggest problems was trying to make sure that the same screen didn't pop up a bunch of times, the same question, you could say. So this happened because we had set it to sort of go in a random order, but because of that, the same question could pop up once or twice or three times, and we really needed to stop this. But we didn't really have the information on how to stop it. So first, we investigated, and afterwards, when we had a sort of like an idea of how to do it, we had to use a while function, and while the while function in Thunkable tends to freeze a lot, so it was just a matter of trying to organize the blocks in a way that it wouldn't freeze. So yeah, in the end, we came up with a solution. This was a solution. So for the second question, how did I with my teammates divide the workload? How were the stages, etc.? They were three main stages. In the first one, we came up with the proposals. We just brainstormed the ideas together, and we had to come up with a basic algorithm description related to computational thinking, figure out what the inputs, outputs, and processes were, and come up with the full proposal generation. And in order to do this, we were in a breakout room, we planned it out together, and then we just each wrote down what we could. For the second part, which was the wireframe, this was basically a mental map describing what the coding or programming was going to be, right? So in order to do this, once again, breakout room, we planned out or decided all of the details and how it was going to be, and then we just each added to this mental map when we could, and that was how we divided the work. And lastly, for the creation of the full app, what we did was she did most of the design. Isai is my teammate. She did most of the design because she's more creatively inclined, and I did most of the blocks because I'm more, you could say, logically inclined. So third question is, what were the proposals that we had? What did we discard and what did we keep? So basically, the idea was first of all, we had a trivia game, a mystery game, and a fashion game. We discarded the fashion game because it was really visual, and that meant it was sort of hard to program. Then we had the mystery game and the trivia game, out of which we put here in our two proposals for the first stages of key activity. So here we discarded the mystery game after we realized that neither of us had really played a mystery game before, so we didn't know what type of clues or things to put there. And we went with the trivia game in the end because apart from being pretty straightforward, we had already both played trivia, and it was simple enough, relatively simple to program. So yeah. So question 4 is basically, what knowledge learned in class do we apply to this, and what extra information did we have to look up? So first of all, we used all the thinkable knowledge that we had from class. We used, for example, relationables, relational operators, logical operators, conditionals, and any type of information given to us by the teacher about design or blocks. Additionally, we had to look up, first of all, how to go from one screen to another, since we didn't really know that yet. But we just figured that out by looking at the thunkable different button options. The next problem was trying to make sure that the same question didn't pop up a bunch of times, like was mentioned in the first question. And in order to do this, we did some brainstorming, tried to figure it out on our own. And when we couldn't, we asked the teacher for help. So we were aided by an expert, you could say. And for the last thing, we had to figure out what the trivia questions were going to be, right? So in order to do that, we just used a website called this 101 Best Trivia Questions, and that's it. So last question, how did the project help us improve our skills in computational thinking? First of all, it forced us to put to use this new knowledge to a real example, and that helped us see a lot of gaps in our thinking and learn a lot more computational skills from that. And additionally, it forced us to sort of learn a lot of new programming things. So that was how it helped us improve our skills.